Hello, welcome everyone, and our Amsterdam Ruby Meetup members. Hi, we have a jam-packed meetup agenda for you with 2 speakers. And oh yes, in case you haven't met me already, my name is Raita, for the new members joining.
Yeah, and my name is Floor, and Raita and I are half of the Amsterdam Ruby organizing team. Tom de Bruin supports today's event behind the scenes, so you won't see him, but he's definitely there, and on YouTube as well.
Yes, and one of our guest speakers is Arno Fleming, and the other one is Julik Tarkanov. So Arno is also a member of our Amsterdam Ruby Meetup organization.
He's totally moonlighting as a guest speaker. I love it.
Yeah, I'm sorry about that. Yeah, he is a guest speaker, but he is also a co-organizer. So sometimes we all guest speak a bit.
Awesome. Yeah. And Arno, Arno will share a little bit about what an investor's sort of mindset can help you drive the decisions that you make for your stack. And Julik will talk about in concurrency fibers and you, which I love as a title, by the way. We'll talk about the new fiber scheduler API and how that matters more than you think. And it sounds a little bit like clickbait, but I've been told that it's not. So there you go. If you have any questions or just feel like chatting with the rest of the community members, then go to our Amsterdam RB Slack or Netherlands RB, I think, Slack. If you haven't joined the chat yet, you can go to amsrb/slack.herokuapp.com. And then once you're in, navigate to the Amsterdam channel and join the chat.
Yeah, you can also let your friends on Twitter know that you're watching our live meetup, and you can also tweet with the hashtag AMSRB in your tweets.
Absolutely.
So please be mindful that we have a code of conduct. And you can review our terms via this link on our webpage. I'll leave it there for just a couple seconds. And I think we can continue with our program now.
Absolutely. So we have 2 talks and they're separated by a break. We didn't schedule any entertainment. I just want to set expectations right. We also need a break after the first talk, maybe. I don't know. Anyway, we don't know how long we'll break because we don't know exactly how long Arno will be talking for. If we know him a little bit, he'll be talking for a bit. Anyway, so you just be back at 8 p.m. CET sharp for the next talk. And Q&A will be 10 minutes, like about 10 minutes after every talk. Just get your questions on the Slack channel and we'll make sure to relay them to the speakers. Talking of speakers, do you want to introduce our first guest?
Yeah, well, sure. Let's just introduce again. Well, he's not a stranger to this community. So Arno Fleming, whenever you're ready, the floor stage screen is yours.
Well, clearly I'm ready. I mean, you even have a picture of my own. No, it's fake. Yeah, clearly I'm happy to start with something that is about called stepping up your game. As far as I know, I'm sharing my screen already, and feel free to just put me there. Yes. By the way, this is a note to both Floor and Raita. Well, first, thanks for the introduction and thanks for having me as a speaker. It's really nice. Yeah, you know me, I really talk too long. So feel free to just start calling me or something. Make it annoying here. If I hear my phone, I know that I'm taking too long. And otherwise, maybe I just don't even respond to it. Anyway, this talk is called Stepping Up Your Game, How an Investor Mindset Allows You to Improve Your Stack. Seem to have no network connection, so that means that you can't hear me, but I know you can. Anyway, Stepping Up Your Game, How an Investor Mindset Allows You to Improve Your Stack, which is, well, stack, we're going to dive into that. So who I am? Well, a co-organizer Amsterdam Ruby and RubyNL, but also the tech lead at The Next Closet. That is important because we're going to talk about experience at the next closet in an investment round. And I'm not going to show you too many details, but yeah, you'll see some of the things that we went through, and well, I'm just hoping that it will allow you to improve your stack. But hey, I'm not an investor. No, but still, this is going to be interesting. This is going to be interesting to you because we've probably made some mistakes, and I allow you to learn from them. So if only for that, it's going to be fun. So I already told you I'm the tech lead at the Next Closet. It's important to understand what the context is. So the Next Closet was founded 7 years ago. Might have been 8 years ago. I'm unsure. I didn't check my details here. By two founders, you see them on the picture, Lieke and Talita. And we, as a company, have a very strong focus on sustainability, because we operate in the second most polluting industry of our planet, which is fashion. And maybe you thought, well, that's not the second most polluting industry of the planet. Well, make a Google about it. So our mission is to make secondhand the first choice. Our niche is the design fashion. Our market is Belgium and the Netherlands. And the total team size, well, that's 20 full-time equivalents. So roughly around that size. This is the full team size. This is not engineers. This is not people in product. This is everyone, including the two ladies you see in the picture. So this is a talk about our journey from startup to scale up, and there's a small disclaimer. The talking points in this presentation are hopefully valid for the Next Closet. They may or may not apply to your business. When putting ideas from this presentation in action, you may come out better or worse. Anyway, it's your business, and your business is not my business. I mean, I told you, I wasn't an investor. So this is about how an investor mindset allows you to improve your stack. So, what is that investor mindset? Well, first and foremost, this is about opportunity cost. I mean, you're an investor, you have some money and you want to invest it in something, and you're not just putting your money away so they can just do whatever they want. You want to have some benefit. It might be more money, or potentially, sustainability is something that would come to mind for us, or maybe you want to have equal work rights, something like that. So benefit usually means money, but it doesn't mean it is only limited to it. But opportunity cost means I can put my money in the bank and get more money by interest. At the moment, that's not really true. But you can also invest it in, let's say, any other company. I mean, we all work for companies, and potentially you're making more money than we do, and potentially investing in your company has a higher financial reward. But benefit is not only about financial benefit. Just you can do whatever you want with your finite amount of money, and well, it has to be worth its while. And that's what investors care about. So two things come to mind. It's about assessing risk. What if I put this money here? Will there be any skeletons in the closet? And two, it's about assessing potential. So you go through some due diligence round where an investor just says, look, there are no skeletons in this closet, but maybe in the next closet. Anyway, that's not funny. But it's also about assessing potential. So this thing that I'm going to invest my money in, will it even scale? Is it something, if I put my money in this idea, will I come out better, or will that company come out better? And well, will we make some money, but also are my goals met? That is not what you do by assessing risk. That is actually assessing potential. And the investor mindset is definitely not about business as usual. So this hairdresser, if you want to scale up a hairdresser, you just need to hire a lot more peeps. And with software, it's different. So investors usually in our game are not interested in business as usual. They're interested in, the growth potential. And then the other part of the subtitle of this talk is how that can improve your stack. So let's talk about stack for a while. Well, we all know the stack, right? It has to do with something about security and development processes, software created, and who owns that, intellectual property. This is not about IPv6 or IPv4, and about your infrastructure. So stack equals stack, right? Given the fact that this is aligned like this and indented a bit, probably there's something missing, which is, the continuity of the team, but also the continuity of, the company as a whole. Also the team composition, but also the culture. This is also what I'm going to, talk about in this talk. Actually, from an engineering management position, the last part is way more interesting than the upper part, as long as the upper part is at least somewhat working. So now we're going to at least go into depth on the tech step. We'll talk about security, IP, development processes, and infrastructure. And it's going to be boring because you see the slide? A lot of text is here. So the fun thing is, this is on YouTube. I will probably share the PDF of this presentation in some way, shape, or form, so you can just read it. That means I'm just going to gloss over them. Please don't read them. Don't make screenshots. I'll share the presentation. Otherwise, it's on YouTube. So just do whatever you want with it. So security. Let's talk about the GDPR. You see the top right, gdpr.eu/checklist. Do it. That's all you need to know. Then let's talk about security. Prepare for some crackers. So make sure that you do something like Zerocopter or HackerOne. If you don't know what this is about, well, it's about pen testing, some security, static security analysis, and some bug bounties. Potentially just an email address is enough. Or how are your servers protected against unwanted access? Make sure to do these things. Install Recatech, install ProRate, install the Linux package fail2ban to make sure you're just going to I can't say that word, poop list everyone that you don't want to have on your servers. Then security. Well, this is for everything after it has gone wrong. Log everything that you're doing. Log the learnings of everything went wrong. Make sure you do this. Then code hygiene. Just know where is your source code. It's probably in GitHub or GitLab or whatever, some FTP server hosted by yourself, like the PHP people used to do. It sits in your developer laptops. It is on your staging and production servers, potentially CI. Does your alerting or monitoring software knows about your software? If you have enough errors and they have enough stack traces, then they can rebuild your software. And are there any forks of your repo? So make sure to think about this. And also make sure that your code base and not your environment. So let's talk about security. Usually, in security, ROI means risk of incarceration. If you do things wrong with the GDPR, it's expensive. Potentially, maybe not incarceration, but this is one of the biggest ways how a business can fail, by just fouling up all the details of your customers. So that was security. Well, that was fast. Let's talk about intellectual property, right? Talk to your lawyer. Yeah, lawyer up. There are things about intellectual property that you don't need my advice about, but you probably, as a company, need some advice about it, so talk to your lawyer. Not a lawyer, your lawyer. Pay them. That was intellectual property. Nice. Development processes. So this is how we go from ideation to implementation. So make sure you order your tech debt. This is still about risk assessment. So from dumpster fire to won't fix, and just start working on the important parts. Reassess all the processes that you have before a request lands in your to-do board. Reassess your team composition. Do the engineers work with the right people? Are they very far away from the end user, whoever that end user is? Or are they really close? So make sure that you have some process set up there. Improve on it. But also how tech is used, about programming languages, libraries, and how current they are. So the code to test ratio, make sure that it's fine for your primary processes. That is how you solve your customers' problems. Make sure to align there. And then how tech is created. Do you do extreme programming, pair programming, just PR reviews, or not even that? Make sure that you're aware of how you're doing it and try to get higher up the thing if you want to have higher quality software outcome. Also, it's more fun, by the way. And how tech is communicated. Do you have some release notes? Do you have release notes of everything, or only the thing that you are, well, very proud for end users to ship? And how current is your documentation? Yeah, make sure it cannot lie. Make sure you optimize for the next hire. They will join, well, unless it's not working out. So other people may decide the strategy. Maybe you will decide the strategy, but each team makes their own operational decision. So that means the team decides on their own tactics. Yeah. So strategy, that's the thing that the people up there do. Then you have operations. That's the thing that the people with the keyboards do. And then you have tactics. How are we going to make sure that we're going to meet that strategy by having operational processes? And you can only let the team fix how the team is working together, which is tactics. How are we going to put all these nice strategies into action? And how do these things that are not working on an operational level, how are we going to change our operational thing? So make sure that the team decides on their own tactics. no top level management on how you organize. It doesn't scale. Let's talk about infrastructure. That's fun. This is about exceptional cases like error tracking, keeping track of outages, making sure you know your uptime. Also, what actually is uptime? Is it just your homepage working? Or is it something else? Decide on what uptime actually means for you. So before you say, well, we have 99.99% uptime. It should be a meaningful number that everyone in your team can explain. And then your infra, does it scale? Did you load test your app? And are there performance bottlenecks? And how did they evolve over time? And what is your server health? Those things are quite important, because if you don't know these things, you don't know if you can scale. And usually investors are not only interested in, oh, you're doing a nice job, but also make sure you can do that nice job for, well, potentially more customers. And then whenever it hits the fan, make sure you have some backup restore procedure. You know how you're hosting, so make sure you can handle OVH kind of issues. And learn from other people's demise. I mean, it was all fun to share that thing in some Slack channel and say, ooh, how's your website working today? But you should just wait another few hours after that and just see, how are they responding to this? How can I learn from something that went wrong? And you probably don't operate your own data center, but you can learn from them. Do it. Make sure you learn from other people's demise. Well, we could talk more about DevOps. So is there any dev QA staging production difference? Make sure to remove everything between development and production. Start feature flagging and start testing in production, because it makes no sense to fix staging. No one is using it if you can use production to test. How do you deploy? How do you autoscale? Do you even autoscale? Do you want to have the headache of Kubernetes, the YAMLs and whatever? If you can just do Capistrano to a data center, or potentially two in case OVH strikes. So pick whatever works with as few painkillers as possible. So most important, in infrastructure, never let a good crisis go to waste, because infrastructure is led by things that go wrong. And I think it was Winston Churchill who said it, but that was just a result of 2 seconds of Googling, so I might be wrong here. So this is about the tech setup. Now let's talk about all those other things that I consider stack, that I consider how you build software, that I, well, consider the thing that an investor is interested in. They're not interested in Ruby 2.6.6 or 2.6.7. They are not interested in Rails 5.2, 4.4 or 5.2.4.2 or 6. Honestly, they don't care as long as it's current. Yeah, if you tell them, well, it's not, but we have these plans, it's good. But telling them it's not current and we have these plans has nothing to do with your tech setup. It has to do with continuity, team composition, and culture. So we've been talking about risk assessment. Let's do the things that are less boring. Your stack's potential. This is about team this is about your team's continuity, the composition, and the culture. And since there is a checkbox, let's also talk about 10x engineers. So not only 10x engineers can add servers to handle 10x load. Not only 10x engineers can build infrastructure no one understands. By the way, not only 10x engineers can secure a website from intruders, and also not only 10x engineers write code no one wants to own. I mean, you can hire me for that. So let's talk about culture and about how a bottom-up culture will help you grow. I said before already that you have strategy, you have operations, and there in the middle you have that layer of tactics. So make sure that that layer of tactics, that is how you're organized, how you're set up for success, so to say, that your team members are responsible for finding and recording the purposes and accountabilities of the work that they perform. I mean, it only makes sense. It only makes sense to, how do I say this correctly? Have the people solving problems. There's something going wrong with the stream, it looks like, or the camera, it looks like. I'm not entirely sure, but I don't see myself moving. I'm just changing. Okay, this changes. The camera doesn't work anymore, but that's fine. Make my presentation full screen. We'll solve this later. Make the team members responsible for finding and recording the purpose and accountability of the work they perform. I'm completely off my game at the moment. This means that whenever you find something while performing the work the operational part of your work, that you make a mental note every time your eyebrows go up, not because of code smells, but because of work smells, things that don't work, and make a mental note and think, well, what is my purpose? Why am I doing this? And make a mental note, what is my accountability? What should I do to perform that purpose? What should I do to make this work? And then make sure that there is some culture where you can learn from every time your eyebrows go up. So connect these purposes and accountabilities that the team members themselves found into, well, you can call them rules, make them visible for the whole organization, and connect them to the team members that actually engage in those actions, who energize those rules. I stole that terminology, by the way, from Holacracy. So then you have those rules, but then something happens. Maybe it's a working from home thing that is happening for everyone, or maybe there's just a change in your business. You're not only going to focus on fashion for women, but you're going to focus on fashion for men as well, or you're going to have an international strategy that is different than just the Netherlands and Belgium. And then your roles, your accountabilities and your purposes might change. So record them, iterate on them, at least on a bi-weekly basis. So new joiners can follow suit because they will be just appointed roles. You can talk about purpose and you can talk about accountabilities. So an example. So there's a team member that wants to join the hiring process. Well, let them make a role for that with a purpose and accountability and hold them to it. I mean, they decided what their accountability and the purpose of that role is after, well, working in it, after being doing some things in hiring. They have an idea for what the purpose and accountabilities are. And if anyone notices, either the engineering manager or the team member, if they notice a mismatch between the role and the reality, well, have the people that own that role change it to better match the reality. So now we've talked about role, purpose, and accountability. That is how you organically grow your, well, working together culture, so to say. Now let's talk about hiring. So use the roles that, well, are hard to fulfill because of other priorities, but they are important to your business, or roles that are unclear to drive your team's education. So use those roles to drive your hiring, but also drive your team's education. So it's not only about hiring, it's about hiring and training. And make sure that in the hiring process, you get rid of interviewer bias. Make sure you don't end up with copies of yourself, because that sucks, because eventually you are going to figure out that this group of humans will just solve their own problems and potentially not, potentially that does not align with your end users. So make sure you train your colleagues. Make sure, if you're just a colleague and not an engineering manager, if you're just, well, operating, working on code each day and every day, make sure you receive some training, because you can always grow. The worst thing that can happen to an engineer is staying on their okay plateau. It's not fun. You don't feel valued. And eventually you're just going to look somewhere else. And then you're going to figure out that you did the same thing over the last 2 months, 2 years even. So, but what happens if you train your colleagues and they leave? Well, what happens if you don't and they stay? That is a worse position to be in. So let's not talk about hiring and training any longer. Let's talk about action. Action is something that can be done with agility. And in some conversation, people will use agility or agile, as if it is a verb, interchange with action. But should they be mixed up? I don't know. So I remember working with an engineer in a slow deciding organization, and that engineer said, when in doubt, always take action. But action does not scale. I know it doesn't sound as seductive as action, but processes do scale. But yeah, so if action equals agile, then process equals lean. So lean is about thinking, agile is about acting. So don't just be agile with everything, because, well, if you're going to build a cupboard, you're first going to make some measurements on the wood before you start getting your saw out. And then you're going to check your measures against your drawing that you have of the cupboard that you're building. And then, and only then, you're going to use that saw, because otherwise you just end up with, well, short pieces of wood that will make a fantastic bonfire, but you won't end up with it, with that cupboard that you're looking for. So think first to make sure you can act faster. So when in doubt, formulate a process, which doesn't sound seductive at all. So process over action. This is not about running. This is about understanding when you should run, but also when you should just hold and just think, make a decision, and just not let, well, action take the better part of you, but always let your strategy deal with which direction you're taking. And you can only make the right decision if you know that you can, well, that you are backed by a process that will dictate action, but that can be changed. Anyway, so underpinning all of your growth ideas is going to be process over actions. So we're getting to the end of this presentation. So Floor and Reita, this is the moment that you get a glass of water and you just sip on it because you'll be in this stream in a few minutes. The first thing that you're going to do if an investor comes by is remove the skeletons from the closet, or at least make them visible where they are, because they care about that. But before that, you do step 0. You create a process to scale your culture, and you iterate on these processes. These processes are going to make it possible for you to grow even before that investment round is over. By the way, the investment round of the next closet isn't over, so I don't know where we're going. And then eventually profit, I hope. And with that, we reach the end of this presentation, and I hope I did it under 20 minutes. I'm just starting a laptop now to see if I can connect with a camera again. Floor, Reita, Tom?
Anyone?
Yes. Look,
I love the casual DHH meme that you put in that for last slide.
Did I?
You did. The profit
unknowingly?
Oh, well, maybe it becomes so ingrained in what we say.
Question mark, profit?
I don't know.
That one? Anyway. We should have prepared this, but we didn't.
I love also how you're still frozen. It's going to be.
I should do that thing with puppets, right? I mean, this is fantastic.
Thanks, Tom, for this wonderful banner. I don't know. Thanks for this talk. I liked it a lot. I need a checklist of this, and I need a blog about this, and I need to teach a course about this.
You call this YouTube, and it's on YouTube.
And then I need to. I know that you can speed up how fast someone talks, but I need to slow you down a little bit.
I mean, this is not a real life presentation. There is no moment where I say this is where you get to take pictures. I mean, the thing is on YouTube. Come on.
That's true. I'll just stop it all the time and be like, yes.
Yes, and just mute it as well. Anyway,
we have a couple of questions.
Right, we have a couple of questions. Yes,
and or comments. Do you wanna start, Reita?
Yeah, let me read up the chat. Okay, so is this rather learning from mistakes, or what percentage of the points you mentioned did you anticipate or have in place?
So the fun thing is, by the way, StreamYard doesn't allow us to remove me from the stream because you can't hear me then anymore. This is really annoying. Anyway, so we have I think 568-page document about the IT due diligence, as it's called, and all these points directly come from there. From the questions that we asked ourselves in preparation, from the comments that the IT team that was reviewing us was making, from questions that investors were asking. And as usual, there's just one way to learn, and it's usually at the moment that you're, struggling to get up again, if that answers the question. So yes.
Did you say that you learned from other people's experience going through investment?
Oh yeah, clearly, because we've received help in the company by an IT specialist who is quite good at doing tech due diligence or IT due diligences.
Yeah.
Is that a plural? I don't know. And so all the hard questions were asked, and we just had to think about it hard and answer them. So clearly, it's just like open source software. That's also why I'm sharing it with the community. I'm standing on the shoulders of giants. I didn't invent all these things. Clearly not. I'm not that smart. Come on. I can just follow a plan or create a process to follow a plan. But these questions that are behind all the things in these slides, they're all about how we were just how the skeletons have been pulled out of our closet.
Yeah,
we still have
exactly.
a few, we still have a few in them, but the potential investors know about them. They're happy with that we acknowledge that they're there.
Exactly. They're always there. So
Yeah, potentially even at Microsoft. I don't know.
So,
no comment.
Yes.
Hello. I have another question for you.
Yeah.
So how do you decide per meeting with the investor or investors how deep you go into technical details and when you want to sort of like keep it a little bit superficial?
Wait, what do you mean?
Like, how do you know when you're in an investor conversation how deep you can go? Because you mentioned like maybe you don't want to be like, oh, we're on Ruby and then I don't know how many decimals behind, you know. Oh, I love this.
Yes.
You see from multiple angles.
Tom, could you please mute me? Yes, thank you. Clearly the questions are going to be asked and you prepare for this. I mean, you don't show up at a job interview unprepared. You at least research the company. And when you go into an IT due diligence, is like going on a conversation for your new job, but then actually for the whole company. So I mean, if you don't prepare like you would prepare your job interview, then you're doing it wrong. You should prepare at least better than that. So if you show up unprepared, you potentially will not get that investment fixed. I should just look here, I guess.
Okay, thank you. We have a question from the community from in our Slack from Maud to Arno. Do you have any thoughts on the ratio in training the team on computer-related skills versus on soft skills?
So how I would decide on training on soft skills or IT or software development skills, I'm hoping that the team members are smart enough to figure out what they do not know. If I'm going to tell them that they are doing it wrong, I'm doing it wrong as an engineering manager, I guess. But yeah, we should be talking about things. I should be able to enable my colleagues to not only work on an operational level, but also on a technical level. And it's hard. I mean, I've been in meetings in and out where I was hoping for my team members to bring points to the agenda. And it's hard because they're afraid that because I'm very strict at what we can discuss about in meetings, that they're doing it wrong. And I understand that they're afraid of that. But yeah, I should train them in how to make sure that they think so much about how they perform their work that they can fix it. And for some people, it's easier than for others. But yeah, you should just have an education budget that you can decide on your own. And in my previous job at WeTransfer, I had a colleague and he had already finished a barista course. I said, look, I wasn't your manager then, but if you're going to do a barista course and I'm going to approve it, that means that you're going to make me coffee for a full year. I mean, if you want to go on a MongoDB course, it was not the case at WeTransfer, then I'm just assuming that you're going to do MongoDB things for a year at least. So if you're going to do a coffee thing, then you're going to make my coffee.
So is it fair to assume that your engineering manager should have like a growth plan ready for you as a developer with both soft skills and technical skills where you can grow into? Assuming also that a developer is more than just a technical person and a coder?
Well, either that, or you're just going to spend a lot of money that you could spend on growing your team members and you're going to spend it on hiring their replacement. You didn't want to hear that, right?
No, I'm just like...
We're gonna let that sink in a little bit.
Okay, sorry.
I have, I love this, more of a comment, not really a question from DJ, who says that it is wise to track downtime, not only uptime, and track the time of day that you experience downtime, because those many nines mean nothing if downtime is at a business critical time. What say you, Arno?
Yeah, we should probably do that. No, so
you're taking notes. So I see that
yeah. I'm taking notes, of course. I'm learning here. Yeah, not only how to present, but also to do the right thing. Yeah. So sure, it's quite important to notice your uptime and your downtime, and you should take note on whether it's a business critical moment. And if you are, well, spent all over the globe, then any moment of downtime is bad. But currently we have a website that is used during lunch breaks and in the evening to shop for nice designer items. So the best moment we can have outage is just during the working day, which is fantastic because all the engineers are present. I mean, you want to do a risky database migration? Sure, it's 3 p.m. Let's do it now. Let's not do it in the middle of the night. I mean, we could better even do it at 3 a.m., but then you have another problem. It means that people have to wake up. And I remember from doing database migrations at my previous job that I fat finger Control-C at those moments. You shouldn't do that.
Okay.
Hope that solved that answered your question, Dirk-Jan.
We can only hope. From the chat, there was also less of fix your hiring or some of the other super valid points that you made aside from security and IP.
Thank you.
Mm-hmm.
Yes.
But they recall sort of the hyper focus also on daily or monthly active users or customer lifetime value. So were your investors maybe less interested in that, or how did you deal with those kind of questions?
So I'm just looking at my slides here. So the thing is, I've been talking to you about the IT due diligence. I haven't been talking to you about our marketing due diligence. Then words like MAU and DAU, daily active users and monthly active users, come by. And we talk about COGS, which is the cost of goods sold, and GMV, which is something that mimics revenue, and all those words. I wasn't involved in them from an IT perspective. So clearly you're going to have due diligence for these things as well. So if you're an engineer, but you're also working hardcore in marketing, you'll find those things, but you will not learn them from me, not today.
Okay.
But that's I'm happy to learn from you. So feel free to pick the mic in some next meetup and talk about how to do a due diligence of the whole company.
Me?
No, anyone. I mean, someone asked this question. If
right.
This is your role and you're interested in the answer, share it when you've learned it.
Okay, cool. I think we have time for one more question, looking at the time here. So from the chat, you talked about processes and documentation. So
Yes.
Do you have like a Confluence or another Docsify? I don't know anything where this all is stored. That is not.
Yeah, I use the word Confluence in there to just annoy the enterprisey people in our audience.
I know.
Yes. But yeah, I mean, if Excel works for you, then put it in Excel. We use Notion. That works until the moment the .so domain is down, or until they ship a bug and your browser doesn't respond anymore. So yeah, we have documentation and we think we own it, but yeah, that's just somewhere in software as a service. But hey, the IT person checking our things said, okay, so you're considering your test suite documentation. That's of course bullshit. And then I said, well, definitely if this is the only way of documentation that you have, then potentially it is indeed not worth its salt. But this is just a part of documentation. This is the part of documentation that you can point to and say, look, this thing is true. I'm not saying that the end user is helped by that, but at least we know these things that are working, and we have documentation on how we believe that the universe should behave, and it's going on green. So this is a truthiness. That still doesn't mean anything if you're not listening to your end users or your customers. But yeah, documentation should live on a code level, should live on, let's say that you are selling things, so you want to have some coverage for your flows that involve money, from receiving money, but also paying it out to your sellers, because if you're going to annoy them, they'll probably find the competition that you'll probably see over the television if you're watching the press conference right now. And so make sure that your documentation is valid on many levels. So team documentation, your roles, your purposes and accountabilities, your meeting notes, they should all just be stored somewhere, just as your test suite is documentation on how you think that the stack should behave in case cracker X enters the same thing over and over from the same IP address. You have some way to solve that, then make sure that there's tests or documentation for that.
I think we have an additional question on this. from Hongli. Are there anybody who resists making processes, resist documenting things, or resist reading documentation? If so, how do you deal with them? Is there anybody? Sorry. Yeah.
Is there anybody resisting this? Of course. I mean, the term mushroom developer isn't invented because they do not exist. There are people, they think they are just only worth their salary if they, sit in the dark and you feed them shit. That is a mushroom developer, right? But a proper developer, you don't keep them in the dark.
I'm just looking at you because I feel like I'm, have you ever heard of a mushroom developer?
Did you know about the mushroom developer?
I did not. So this is something new today.
Yes. Okay.
Please
today.
continue.
Okay. So there are developers, and they'd like to be kept in the dark, and you just don't tell them the actual plan or the expected outcome, but just the plan that you concocted for them. That doesn't scale up, by the way. So you will always have developers, and they just tell you, well, just give me tasks to do. They are probably valuable because they are in your team. They can probably build something really good because they are in your team, and they are valuable colleagues. But it doesn't mean that they are the best people to scale your processes. But you have to involve them anyway, because you want to grow the team, and it means that even the 10x engineers that do not want to think about how to get better at your process, their input is very, very, very relevant. So if you have an issue like that, and this is also a note to self, if you have people like that in your team, make sure that you do a course to start listening to the listeners. And especially for me, being an extrovert, that's really hard. So, and if you're struggling with that, try to listen to the listeners, and also ask for micro reflections. So at the end of the meeting, just say, look, I did it this time this day. Did you notice it? And does it work? And then learn from it. I mean, and keep notes for yourself. If you notice that it works, keep on doing it. If it doesn't work, change it.
Plus, you give them the book, The Art of Action, right?
Potentially, if they're interested in it.
You recommended it to me.
Yes, no, it's a fantastic book. But I mean, let's say that you're a mushroom developer, and you just don't want to think about your process. You're just doing the thing as it comes natural. Then it makes no sense to start thinking about the book, The Art of Action, because that is how leaders make sure that the gap between ideas and actions are removed. Potentially, you want to give this book to your leader if they are top-down managing you, and potentially you want to learn from it and start training your team on getting better at it. But it is a bit of a tough sell to a person in operations that just wants to stay in operations. But Scrum and XP from the trenches might be a better fit then.
Yes, I have that. I can share that with you.
Yeah,
share it in the chat.
No, you can download it. It's free on the interwebs.
Yes, but otherwise people don't know where to go.
In Slack.
You're giving out gems here, and
in Slack. We'll put it in Slack.
Thank you.
Yes.
Appreciate it. And now we'll take a break after this.
Yes. Yeah. Okay. So we will be back in 15 minutes or so, like 5
Maybe
minutes.
A little less. 10.
10. Okay, 10. We'll be back at 8 o'clock.
Also, I feel like it was a really hard breakup of Arno. Sorry, Arno. Thank you for your talk. It was wonderful.
Yeah, he was just cut off like that. Maybe because of the mushroom developer thingy. Oh, there he is.
I'm just happy. Please break me
Cool.
off.
Thank you.
Why am I
That's great.
back? I was already gossiping about you.
Thank you so much. I learned something today. Like really, my eyes were this big.
I don't think it's what he wanted us away from, but that's fine as well, isn't it? Anyway, after the break, we're back with another talk from Jüllich, and we'll learn
fibers and you.
Yes, and we'll see. We might recognize the backdrop from Arno.
What's that, Arno?
What?
Huh?
Wait, what? What's happening?
Something's happening.
Arno,
Okay, peeps. See you later.
Welcome back, everyone.
Badger. It's stuck in my head. Welcome
All right.
back, everyone.
Let's pretend to be serious. So our next speaker is Julik, who is also no stranger to this community. Julik is an HKU graduate, that is the Utrecht Art School, speaks 4 languages, including French and Russian. And since 2014, he works as a lead engineer at WeTransfer, and in his own words, creating Ruby magic both for open and closed source projects. And so, Julik, when you join us on the virtual stage, we welcome you to get started.
Hello, everyone. Thank you.
I feel like I've seen that backdrop before.
Thank you for having me. Yes, the backdrop is repeating. So I figured out that for some reason Arno has hijacked my attic, and so as soon as I found this out, I had to go here and I had to expel Arno from my attic because I also need to present. But that also means that Arno could break my webcam and my keyboard and the microphone, and he also removed the badger from the microphone stand, so it's all good here. Anyway, let's get started because we got a lot of material to cover. So
Yes.
I wanted to talk with you about concurrency and fibers and what it most likely means for you. And also I wanted to talk about, in my view, the most undervalued feature which has been released as part of Ruby 3.0. A short kind of introduction. Who am I? I work at WeTransfer. I'm a senior software engineer, and I lead a team which is called Sudo, which is responsible for all the storage uploads and downloads needs of WeTransfer. And for example, one of the services that we run is a very heavy streaming web proxy service written in Ruby, and we'll get to why this is relevant in a minute. So a little bit of a warning about this talk. I am not a good computer scientist, and so there is going to be hand-wavy statements. I'm going to do a little bit of fear-mongering, and then I'm going to try to indoctrinate and suggest sternly. If that disappoints some people, I'm very sorry, but I think this is an important subject, and I think it deserves a little bit more attention than it gets at the moment, let's say. So the whirlwind tour of Ruby concurrency and parallelism. We'll get to the difference between the two shortly. There are good examples. Everything's going to be nice. We have 4 units of concurrency or entities that we can use to do things at the same time or in sequence, but we'll get to that. So in Ruby, we have the process. That's the Ruby virtual machine that you start. We have the rector, which is the weird new thing. We're going to touch on that also. We have threads and we have fibers. Most likely you have not used fibers, or at least you haven't used them explicitly. We'll get there, and I'll explain why fibers kind of rock for a few purposes. So the process, like I said, it's a Ruby virtual machine, and it's an operating system level primitive. So you start a process, the operating system is responsible for pausing it, for stopping it, for giving it more resources or less resources, and every process gets its own isolated memory address space, which is kind of important because that's how different applications on your computer cannot grab data from each other's memory and do kind of nasty security things when they shouldn't. And every process gets its own Ruby virtual machine, which means that you cannot, for example, load your huge Rails application into one process and have other processes use the code that you have loaded into the first process, where you can do it to an extent, but the benefits of this heavily minimize as your processes run for a longer period of time. And it's also a hack, and you should be doing this. So anyway, it's just not good for saving memory and too isolated. Then we have the rectors. The rector is a new thing, again, introduced around the Ruby 3 timeframe. And a rector is kind of a crossover between a process and a bunch of threads. And the idea with rectors is that you will finally get an isolated virtual machine inside of your Ruby virtual machine. So you can run multiple processes at the same time, and they share the Ruby code that they are running, but they are not sharing the memory with the data they are operating on. that's actually the problem why rectors are very hard to use at the moment. And I don't know whether this problem is going to get solved in Ruby ultimately, because in Ruby, data and code are very hard to separate, and rector imposes some degree of separation of that sort on you, basically. Then we get to threads. Thread is an even smaller entity, and a thread is something that the Ruby virtual machine knows about. But it's also something that the OS knows about. So when you run a thread, imagine you have your Ruby program and you are doing a call to a Ruby gem, which provides bindings to some C library, which processes images. Now, if this library, which processes images, can do multi-threaded stuff, so do multiple tasks in parallel, and you can tell it, process me this image and use one thread for that, and process me another image and do it in a different thread, then basically the threads of the Ruby virtual machine will map to that. And so you can use library native code which is multi-threaded from those Ruby threads. Threads are concurrent and parallel, and the important part is that even though a lot of people kind of assume that Ruby threads are dead weight because they never execute at the same time, this is not true, and I'm going to show you how that happens slightly later. And a fiber is an even smaller thing that you can use to keep multiple things in motion at the same time within one Ruby virtual machine. And fibers actually share the thread that they live in, but the important part is that fibers never run at the same time. They always run sequentially, and you cannot be running two fibers at the same time. So you can be running two threads at the same time, because threads in Ruby do run in parallel sometimes under some conditions, but you cannot run two fibers within the same thread at the same time because fibers are sequential. That's the important part here. Now, what's the deal with concurrency and parallelism? There is a great explanation by Rob Pike, who is one of the authors of the Go programming language, about the difference, but we can cover this quickly. And what I want, and I guess the simplest way to look at it is that you benefit from parallel work if you know exactly the amount of work that you need to do. You have a fixed number of engines or people or processors or whatever which do this work at the same time, and then you just drop this work on those processors, and you want all of them to be doing this work independently. And when you have concurrent work, it means that you have certain execution flows or people or engines or processes, right, which can be interrupted and then resumed. So a great example for parallel stuff is when, imagine you have a very large bar and you have two bartenders and you have an endless stream of guests because it's a large music festival and the Corona finally ended and everybody wants to have their beers. And then we know that the two bartenders are going to serve two guests in parallel no matter what, because every guest takes roughly the same time to serve. There is a very large queue of guests and we have two bartenders, all hunky-dory, right? But at the same time, imagine that we all can go to meetups again, and then you are talking to somebody between the talks. Imagine I'm standing in a corner with Arno. Well, right now Arno is sitting here, but imagine hypothetically we're again standing in a corner with Arno and we're talking, and then say Raita comes to me and said, Jurek, can I talk to you for a second? What will I then do? I will concurrently talk to Raita, because I will tell Arno, Arno, I'll get back to you in 5 minutes, and then I'll go talk to Raita. But once I have spoken to Raita, then I'm going to go back to Arno and I'm going to resume my conversation with Arno. So yet, while this was concurrent, because my conversation with Arno hasn't finished while I started talking to Raita, it is not in parallel because I cannot be talking to two people at the same time. That's roughly the difference between parallel and concurrent. Why this matters? It's because for when you are doing something parallel, there is a small number of conditions where it's extremely important to you. For example, you need to render an image, or you need to do car recognition when you have a self-driving car, for example. Like you do need something very computationally expensive, which you know is going to completely consume your available compute resources. And the amount of compute that you need to perform is known and finite. And funnily enough, it's less situations than you think. By contrast, when you want concurrency, that's where you want concurrency, because if you are servicing web requests, a lot of people are making connections with your web server, with your application. You don't know how slow all of these clients are going to be or how fast. One client might easily be 100 times faster than another. So you don't know how much time it's going to take to service every client. And you're also talking to a database. Imagine that at the same time when you are doing a database request, a data analyst from your company is running a huge aggregate query, which joins 7 tables together, and your database just locks up and it's not giving you a response. What you're doing, you're waiting for the database to give you that result back, right? And no matter how many processing cores you have in your web server or how extremely parallel your runtime is, right? Your database is not going to give you this result faster. And the client which is connected to your application is not going to supply you their HTTP request faster than they can, right? Because the thickness of the wire is just not there. So imagine we had in Ruby, we had absolutely extreme, full, complete parallelism. It would have been nice. Like I would love to have it. But imagine we do have it. So we want to service 10,000 web requests at the same time, or we are doing or we are running something like in the early days of WhatsApp, what was like a grand showcase for Erlang. We want to have 1 million chat channels open, right? And our computer has 64 processors. And we do not have concurrency, and we only have parallelism. Well, how many of these web requests can we service at the same time? Surprise, exactly 64, because then all of our cores are busy. And what is going to happen is that those chat channels, they will be extremely parallel because every chat channel gets a CPU core, but what they're going to be doing is that they're going to be doing nothing. So you're going to have a machine which consumes energy waiting for those chat messages, and your entire AMD super duper Ryzen Opteron 64 core unit, which is this big, the only thing it's going to do is going to produce heat, right? And it's going to wait. So with concurrency, however, it gets more interesting. You have the same setup and you have 1 million chat channels, for example, but when they are idling, they are at a minimum cost to you because you do not need to parallelize them in any way. They can just be sleeping. Like an interrupted conversation, they can just stay in the background. And when you know that you are receiving a message which is supposed to go into one of those channels, then you pick up this message and you multiplex it into the channel, and then this channel consumes some amount of computation if you need it to, right? And then again, for that channel, if you need to send the data to the clients, then you try to dispatch it to every client. And if the client takes longer to receive the messages on this chat channel, well, you move on to the next client. And so that's why fundamentally concurrency is way more important to you than parallelism if you do the web. I would say, like, I've met very few situations where I really needed true parallelism, extreme parallelism over CPU cores, but I've met dozens of situations already where better concurrency was like, it was a requirement. And how can you best visualize concurrency? So if you think about how your program works, then the best way to think about it is to think in timelines. I believe in the UML diagrams, traditionally, the timeline of execution is top to bottom. I'm used to working with video, so for me, timelines always go right to left. So we're going to use that representation. And in terms of code, it's a bit hard to visualize with words. But what you can do is you can take two small pieces of code that your application is using, and you can try to see what would happen if the lines of these 2 units of code would cross like this. And then you would be able to imagine that, okay, so now my computer executes this line from this thread or this fiber or whatever, and now it executes that other line from another thread or another fiber. It's a bit mind-bending, but it can be done. How do all of these concurrency primitives that we have fit together? We're not going to be talking about Ractors because I think that at the moment Ractors are not practical to use for all intents and purposes. And I think Kir Shatrov has written a nice article about writing a web server with Ractors and what problems you actually encounter if you try. It's really, really instructive. But basically, if we look at the timeline view for threads, then we're going to end up with a picture like this. And imagine everywhere where we have red, it means that the thread is doing something useful, right? That it means that it does useful work, right? We're going to get to the tricks with the definition of the useful work. However, in Ruby, achieving this is not possible because we have what's called the GVL, which is the global VM lock. And the global VM lock is a safety mechanism which ensures that no two pieces of native machine code can touch the Ruby data structure. So, for example, if you want to create a Ruby string, the global VM lock ensures that only one thread can allocate and create this Ruby string. And that's a historical thing, but it also makes developing, say, C extensions for the Ruby virtual machine, for C Ruby, much easier. And many people assume that if you have this problem with the GVL, then it means that your threads are always going to be executing sequentially. So one thread executes for some time, and then it gets suspended, and then the thread 2 executes, and then again thread 1 executes. And so basically you never get any kind of parallelism, you just get some concurrency. However, this is not true, because if your gem that you are calling out to performs some native computation, say, for example, if you are processing an image and your gem is written well, what the gem can opt out to do, it can tell to the Ruby virtual machine, I'm not going to be touching any Ruby data structures. I'm just going to take the path to the file that you gave me, read the pixels from that file, and then do something with those pixels. And by the time I'm done and I can return you those pixels, then I'm going to ask you to give me back the lock. And most well-mannered C extensions do this. They can make those guarantees, and that means that multiple threads can actually execute native code at the same time. If we denote the blue regions as regions executing native code, then you can see on this graph, for instance, that you can have a situation where multiple threads work in parallel, and that happens pretty often, actually. And again, in some situations when you are about to read something from a database, or you're about to read something from a socket, then you can get a situation where your threads are going to be put to sleep because they wait for input-output, which means that other threads can execute at that time. A typical situation would be when you have one thread which handles connecting clients, right? Something like a web server also. And then once a new client connects, it gets dispatched to a worker thread, and the worker thread handles that client. But it doesn't mean that this acceptor thread, which takes in connections, it doesn't mean that this acceptor thread has to be executing Ruby code all the time. It can just say, hello, Ruby virtual machine, I'm going to sit here and I'm going to wait until somebody connects and wake me up only then, right? And then other threads can be executing at the same time. So what is the deal with threads? We're going to get to that, but the thing is that it's hard to create many of them. So for example, if you have 100 threads, things can get interesting because every thread has an underlying OS primitive underneath it, right? And that costs you some memory, that costs you some performance, and the OS is going to be kind of trying to co-manage your threads together with the Ruby VM. So that brings us to fibers. Now, you likely haven't used them manually, and you are using them when you are using enumerators. So for example, if you are doing a map.withIndex in Ruby, then congratulations, you are using a fiber because you are using what is called an enumerator, and due to the quirks of how the Ruby virtual machine is built at the moment, every enumerator is also a fiber, right? I've written an article a while ago for the AppSignal blog, I believe, where I cover what you can do with enumerators and fibers. But for understanding what fibers are and what they're useful for is actually, this is kind of the gist of it. So imagine a piece of code which executes and then just stops, right? It stops. It doesn't mean anything. It means that you can still do, input. You can continue typing into IRB. You can continue handling web requests. You can even process an image or do whatever. You just have some block of code which got into a certain place, and then somebody pressed the pause button, right? And it does nothing. And often you would use it, for example, here, right? So you create a fiber, and the fiber is called a holder of state, holder of state. And then you enter some state inside of your fiber, and then you say fiber.yield. Fiber.yield is you pressing that pause button from inside the fiber. So you perform some work, then you say, okay, now my fiber is frozen, do whatever else is necessary, and then call me back when I should resume myself. And then when somebody calls us with the holder of state.resume, we get past the fiber.yield line, right? And we exit the state that we have entered. Like it can sound funny, like enter some state, exit that state. Oh yeah, another thing is that a fiber is really a block of code, which means that you can be in a loop there. So you can have an operation of entering some state and staying in that state for some time in an infinite loop. And you can resume it all the time, because this block of code, it will actually be resumable an infinite number of times, as long as inside of this block of code, you break out of your loop do construct. And so your fiber is not going to terminate with this setup, right? Now, the first time I saw code using fibers, my thought was like, who would ever need this? Like, why would you do this? And some time ago, I've encountered a case where you can actually use fibers for something very, very, very useful. And you can do a trick like this. Now, we are testing some kind of lock, right? And we need to test that the lock is acquired and that the lock gets kept. We try to do something which checks for this lock being locked and fails, for example, right? And this way we have a test which ensures that our locking system is good. And then you can do it with a fiber like so. So we create a fiber which acquires a lock and then just hangs in there, right? And then we can resume that fiber. We know that a lock is held in that fiber, right? And then we say assert equals held locks count, and that equals 1. So we have some way of knowing how many locks we have acquired, and then we have 1 lock, right? And we hold it. And then we call our testable lock state with resume, and it means that we continue past the fiber.yield and we go to some lock.release, and it means our lock gets released, and we then test for when the lock gets released. This looks extremely stupid, because you say, oh, if you say some lock equals acquire lock and then you do the fiber yield, why the hell do you need the fiber for? Well, that's where the code blocks come into place, right? Because there are actually a lot of APIs in Ruby which work like this, right? So you use a Ruby block to enter a certain piece of state, and you need to check whether certain side effects can be observed when this state is in effect, right? And so if you have a block which gives you, if you have a block which puts you in, which acquires you a lock and holds that lock for you, right? Then you can only test this effectively with a fiber. And then what happens here is that we enter this block inside with lock acquired, and then we suspend inside that block. And then if we are testing our locking solution, this means that we can always reliably and deterministically ensure that when we make this assertion, we are hanging here with the lock acquired, right? And for instance, testing things which are a little bit concurrent, maybe, this is very useful. One of the reasons is that those fibers, you determine when they resume running and when they stop running, and only one can run at the same time, meaning that you have deterministic concurrency here, right? Now, resuming, you don't have to resume a fiber once. You can resume it an unlimited number of times. And the funny thing is that the way it would work is that if you have a lot of those fibers, what you would be actually doing is you would be picking which fiber is more economical to resume right now. For example, you have one fiber which does something with a slow client. You don't want to resume that fiber because your client is not ready to send you data. But you have a second fiber which has a fast client, and then you would resume that second fiber first, and then you would try resuming the first fiber again, right? When multiple fibers exist in your address space, what happens is that they exist at the same time, they are alive at the same time, but only one can be running. Like I said, they're sequential, right? So if, to make it easier, you can always say fibers are for sequential execution, and then think about the concurrency implications. How would you do like a web server which uses fibers? Likely you would have something like this, right? So you would have some kind of a client socket object that you read from and that you write into. And then you would create a fiber, which is dedicated to this particular HTTP connection, to this particular web server client, which is connected from the internet to you, right? And then you would feed the data from this HTTP connection to your HTTP parser, and then you would grab, for instance, one of your Rails controllers, and you would call the action on that Rails controller, receive a result, and then write the result into the client, right? So far, this is like very straightforward code. It looks just like any other web server code would look, and that's true. But the interesting part will happen here, right? So imagine that when your web server encounters some kind of slowness, for example, during its reading of the upload that the internet customer has sent to your web server, for example, if they're uploading a file to you, or if they're sending a CSV, for instance, or a large JSON request, right? And they are slow, and you cannot read fast enough. Or if your Rails controller does a MySQL or a Postgres query, which is taking a really long time, right? What we can do then inside of a fiber, if something gets slow, we can say fiber.yield, which means that we are waiting on something and something else can do useful work while we wait, right? And this means that in every operation which can wait for something, or every operation which can encounter slowness of some kind, what you actually want is that you want automatic pausing. So you want every operation which can be consuming resources on waiting to yield, right? And with basically you want this, right? So you want your database query methods to yield, to fiber yield when they will be waiting. You want your IO methods to read at the minimum. How is this better than threads? Fibers are way cheaper. Like I said, you can easily create 100,000 of them, and your Ruby virtual machine will be fine. If you create 100,000 threads, it will be quite painful, right? And they consume less memory, fibers, and they are also deterministic in the sense that they are sequential. So you can you can reason easier about which fiber is going to run first. And that's kind of the first part of the equation. And the thing that it's important to know is that this is like the two methods. So we have the pause button and the resume button, which is the play button. And the first innovation that we get in Ruby 3.0 is you can make it so that pretty much all of the IO operations in your virtual machine automatically are going to call fiber.yield for you. Like, how awesome is that? So you can start developing a fiber-based web server or a fiber-based chat server or a client now, and you can just by configuring your Ruby virtual machine in some way, you can make it so that every IO operation that you do is going to call fiber yield automatically, so that you do not have to manually implement this functionality in your application code or in your library or whatever. And the trick is that you also need something that resumes your fiber. So you can yield from the fiber. That's really cool, right? You can pause your work, but you also need something to restart the work once it's known that your work may continue. For example, your client has finally sent you some data and you can process it, right? And most likely this looks kind of like so, right? If you have a web server, then you would have some kind of loop which has a choice between multiple connected clients, and by using some logic or some heuristic, it's going to determine which of these clients can be worked with now, and it's going to resume the fiber which contains that client, right? And that's what the Fiber Scheduler API has in stock for us. It literally allows us to say, within this thread, we're going to be using this scheduler. A scheduler is, for our intents and purposes, just a Ruby object which has some methods, and you don't have to write your own. You can grab one like a libvish scheduler, etc. And in that instance, all of your fibers which are going to have to be resumed are going to be resumed by the scheduler. So for example, you don't need to play around with Neo4r, for example, if you want to have a web server. You don't need to ensure that your fibers get rescheduled at some point later in the future if your clients disconnect, etc., etc., etc. This scheduler is supposed to do all of this for you automatically. And so that's why that's a really important feature. And the thing is that, the concurrency that you can have with fibers, exactly because of this sequential nature and manual pausing, I can tell you, it's way nicer than JavaScript promises, right? And let's remember that Node.js, it started because people didn't like having to do concurrency with threads, right? It's way nicer than Python async await because it does not give your functions color. In Ruby 3.0, you can have a situation where you can call all the functions doing I/O as if they were sync, but they will do asynchronous stuff for you. They will yield for you, which is very similar to what you have in Erlang and Beam and Elixir. They're nicer than Ghost coroutines because they do not impose channels on you, and you don't have to do channel select and things like that. And it's basically just as nice as Crystal because, surprise, surprise, Crystal from the beginning had fiber-based concurrency, and it worked exceptionally well. Now, we're getting to the last part, and here this is where fear-mongering begins, right? Let's be clear about this. So let's not pretend, right? People do want to handle a ton of connections on their single application node, right? People do want to have a server updated live view with their tables and their graphs and their input elements, right? This kind of concurrency was the reason Node was created, because Ryan Dahl, when he initially presented Node, even before it was shepherded by Joyent, he said, for web servers, threads are out, and you want evented I/O. Well, evented I/O then has to be used in some way by the client, and that's going to be either callbacks, or it's going to be actors, or it's going to be goroutines, or it's going to be fibers. But some way this has to be present. Better concurrency is why a lot of people went to Go, because in Go you can create 10,000 or 50,000 goroutines. And what are these goroutines? Well, they are just the same thing. They're basically those same fibers, right? They are abstract constructs which the Go runtime schedules onto actual threads when the Go runtime thinks that it's appropriate to do. And better concurrency, the presence of async await is why people are moving their applications from Python 2 to Python 3, right? And certain things that we might want to have in our applications, like Phoenix Live View, right? It's only viable when you can have cheaply a lot of people connected to your application at the same time and idling, right? Certain features should not require you to run a separate process written in a separate programming language just for the sake of having those people connected to you without running 50 servers instead of 2, right? So there is a class of tasks which, without having this concurrency, we cannot do with the Ruby programming language. And this is where things get difficult, because if you are a company who is now evaluating which stack to choose, right, then there is always Team Purple, and there is always Team Yellow, and there is always Team Bondi. And if you are, say, an engineering manager on a polyglot team, and then they're saying, oh, so, we can write this application in Rails, but we are likely going to be getting some WebSockets. And yeah, I heard that WebSockets, they use so much memory that we can never implement this in Ruby. And if you are realistic as an engineering manager, you'll say, okay, we move up left, up right, or downwards. Or if you are an extremist, you would say, yeah, let's try Crystal. But basically, those people and those challenges in developing applications for people, they go away and they don't come back. And that's how our ecosystem shrinks. That's actually the important part, right? So why this fiber scheduler matters to you ultimately, it's because I believe that if we do not adopt this, right, the ecosystem is going to continue dying. Again, it enables new classes of applications being built. It makes hosting Ruby applications cheaper, because if you get cheaper concurrency, you need less memory and you need less machines, less Kubernetes pods, less whatever you have which runs your application. And it makes it easier. And in some way, I would say this is one of the things which makes it permissible again to suggest Ruby for a greenfield system development, right? So what can we as just journeyman developers do if we want to try this, or if we want to see whether this initiative can succeed? So one of the important parts is that at least we should try to develop applications which do not use Rails. Why? Because all of the innovations of the Ruby ecosystem end up in Rails maybe 2 years after they happen, maybe 3 years. They have to be adopted by a relatively large number of stakeholders which use Rails, right? And by the time that happens in Rails, like for example, I don't know when Active Record is going to be fully working well with the Fiber scheduler API. It might be this year, it might be end of this year, it might be start of next year, or it might not happen because there's going to be some debate between the author of the Postgres driver and the MySQL driver. In reality, we don't know, right? So the first thing that you can do is try to write an application without Rails again and see whether the workload that this application has can be fit into this new Fiber concurrency setup, right? So that would be one suggestion. Second suggestion that I would have, if you have an application which doesn't run on Rails, try running it on Falcon. And Falcon is like the first and the most intensely developed web server which implements concurrency using fibers, and so you are likely to discover quite a few interesting things in there if you try it. And recently there came a pull request which adds a Fiber scheduler to Puma. So for example, if you have an application which is not in production and that you can run some load testing on, well, you know what? You can check out this branch of the Puma repo, and you can just try starting your application on Puma and see what happens. See how many connections you can handle. Who to follow? So first and foremost, Samuel Williams. Samuel is an amazing person, and he is behind both the Fiber scheduler API and the Falcon web server. And he also has published a lot of research on the topic of why this Fiber-based concurrency is actually the answer for us at the moment and why it deserves full attention. And the YouTube link that you have here is a link to his presentation on RubyKaigi, I think, where he explains his points in more detail. And he's an amazing person. Follow him. And last but not least, the treat is that on the next Amsterdam RB session, as far as I know, Mr. Van der Hillen is going to drop by and actually tell you how a scheduler looks like from up close, what you need to watch out for if you're using one, and also what kind of problems you can encounter if those fibers are not purport to be, because they're supposed to be cooperative sequential processes. But what if one of them is not so cooperative? Vander is going to talk about this in more detail. I think we're already over time, but that was all. Thank you very much, and I hope I could inspire you to look into fibers a little bit.
Thank you very much, Julie. Yes,
absolutely. I just want to say it's the best explanation of what concurrency is versus parallelism in terms of threads that I've ever heard. Also, I want to confess that only 20 minutes in, I got like, oh, it's Fiber because of threads. I am so ashamed.
Probably the next unit is like hair splitting. I don't know, but that's why they called it like that. Yeah.
It was just like, why is that? And then I'm such an idiot.
It's fine. You're just a little bit concurrent. It's fine.
Arno, what were you saying?
Regarding?
See, I was trying to concurrent with Arno, and it didn't quite work.
Yeah, nice. I'm just gonna Fiber yield here, so go ahead.
All right. So I don't know what happens then. Do we have time for questions or?
Yeah, of course. I mean, we are Amsterdam Ruby meetup, so
right.
time
so
for.
how
Yeah,
do we
we
go about this?
We have a couple of questions in Slack, and I think we have a couple of questions for our own. Let me just scroll back a bit more. Oh, we started with fashion, of course, because we had confusion about the fibers, and then we had the yarn pulled in, and then so it was,
Okay.
sorry, yes, yeah, we were triggered. Okay, so and then we had a bit of a I think a miscommunication about go routine versus co-routine. So we have a question here from Derek Jan. That is, so it sounds a lot like coroutines. Are fibers coroutines? If not, how do they relate to coroutines? And for those who don't know, a coroutine is a subroutine, functions, processes, etc., that allows its execution to be suspended and resumed.
I would wager that yes, fibers is just a Ruby name for coroutines. Yeah, I think that's the closest thing. But I was trying to figure out like the specific computer sciencey definitions, and I'm sure there will be some people in the audience who are going to explain the important differences between fibers and coroutines, because that's where my hand wavy warning came from. Huh? I've just done art school, people. I'm like.
Hey, same here. I do love computer science definitions. I have a question for you, because you talked a lot about the sort of the Go language and ecosystem. Are there any other Go influences that you would like to see or that you're expecting to see in Ruby?
Go influences that I would like. Well, I would love to see monolithic binaries that you compile and then provide as downloads from somewhere for 4 platforms built from one machine, and that they just work and they don't require installation of anything whatsoever. That would be rad, but I don't know whether it would happen. It's like the coroutines or Go routines or fibers or this sequential concurrency is not the only reason people move to Go. Like Go has a lot of things on the table, but there is also a class of problems where they're eating our lunch. That I think is true.
Yeah, but you can take inspiration from, right? And so if there is a little wish list that you could be like, okay, those things I want to have from Go or maybe from another language, what are some of those things that you want to be having?
For Ruby, what I would like to be having, well, I would love to have true parallelism still. I would like to have immutable strings for certain, and maybe I would like some kind of type inference, but I'm not sure. Like maybe just good bindings to Qt UI libraries would be nice, and that's it.
Another question, how much are you able to use fibers in production at work?
We use fibers in production at work a hell of a lot, because at WeTransfer we are using LaunchDarkly, and we are using the LaunchDarkly SDK, and the LaunchDarkly SDK uses the socketry async libraries these days, and so de facto we use fibers when we talk to LaunchDarkly from our Rails application. That already works. And we also have an experimental variant of our download server, which works based on fibers and which runs on the Falcon web server. We've done some experiments using that in production. It was mostly successful, but there were a few things that we couldn't get worked out at the moment. So for example, our server would run out of available sockets for people to connect, because those fibers would never be forcibly terminated when people weren't. Basically, there is a situation where people are no longer connected to your machine, but your machine still thinks that those people are connected, and those connections, they consume resources. And so that was something that at the time Falcon couldn't deal with very well. Maybe we're going to do another round of testing. I'm not sure. Depends.
Thank you. I think
if you have any more questions. Also, I have a hard time concentrating.
Yeah,
that is imaginable.
Yeah, I think so. Slack just exploded. It's super nice, and it was a very nice talk, Judith. Thank you very much.
My pleasure.
So I think our next meetup will be on.
Wander is even saying like it was too good, so maybe he doesn't want to follow up now.
Well, it's a benchmark now, so
Good.
Wander ain't getting out easy.
Yeah, you should definitely check out our Slack channel because people have opinions.
I imagine.
Yeah. So we do miss your Friday rant though.
Yeah,
in our Slack. So whenever you feel up to it.
Friday rent are a little bit delayed, but I do have. I'll think what I can do about this. Let's put it this way. No promise. No commitments. I'll think I'll see what I can do.
Maybe it means that Yulik is very happy right now. There's nothing to rant about.
Well, it's not Friday.
That laugh says,
it's not Friday though, huh? You never know what will happen.
Yeah, exactly.
Yeah, a couple more days to go. Let's see.
Well, thank you very much again, Yulik, for your time and this amazing talk. I learned a lot about fibers. I had no clue, to be honest. So I really did learn a lot. Thank you.
My pleasure. Thanks for having me.
Thank you.
Yeah. So I think this concludes our Amsterdam Ruby meetup. Our next meetup will be on the 18th of May. Maybe it will be about something Floor mentioned. It was whispered in my ear, like maybe she was inspired by fibers.
Yeah, with all of the fibers and the yarn, and I was just like, well, I can do some actual knitting. Like it will not be metaphorical knitting though. So I'm not sure how many people will be interested in that. Anyway, I'll definitely not do that on the 18th of May. Do we have our speaker lineup finished already for the 18th?
It's not finalized just yet. So if anyone has like a super nice, interesting topic they want to talk about, then you can find us in Slack for sure, or Twitter, of course. We would love to have to hear more about these talks, like whether it's about a Ruby related talk or more about soft skills or processes or whatever helps you in your development work. Or that's amazing. So hit us up then. Until then, have a great evening.
Wait, I have a couple more shout outs.
Oh, sorry, go ahead.
So the recording of this meetup will be up shortly, right? On the YouTube account for RubyNL. I want to thank our speakers one more time. I want to thank everyone tuning in today. I want to thank Tom for being backstage, making sure that, like, everything runs smoothly, and for the little commentary in the banners. I feel it was great. That meetup is on the 18th of May, but we still have a Ruby meetup this month. I mean, probably for different cities as well. But there is a new meetup for women and non-binary folks called WNB.RB. You can follow them on Twitter via WNB_RB. And I think they have their next meetup on the 27th this month. Not sure, but you should definitely check that out.
Yeah.
And this is the moment where we were like, until next time, and then we do the awkward wave.
Yeah. But before the awkward wave, can you paste the link into Slack, and then we do the awkward wave?
Yes.
Okay. Do we have time for the awkward wave? You know the thing. So people just said in Slack that when we say hi, then people just scream hi at their screams as well. And when we wave, people go like, hi.
So we can do that. Dikke doei.
Too. What?
Dikke doei.
Yeah, dikke doei. Now do ya? Do the awkward wave, Floor.